So moving on to our next video lecture of our geology series, chapter 7, geohazards. So basically in this we are going to study about the uh, natural hazards and natural calamities which occur on our planet Earth. Okay, so let's begin. So I'll give you the important markings. Okay, so the first part talks about earthquakes. um, Earthquakes, they have given an example over here. Okay, so the earthquake which had occurred in Portugal killed almost this much 32,000 people was a benchmark regarding earthquakes. So because of this earthquake occurrence, a new branch of geology occurred, which is in the branch of seismology. So seismos means earthquake in Greek. Okay, then after some time, another earthquake occurred in China. Okay, which almost kills 8 lakh people. Okay, then in detail studies were done about seismology. So the first part about earthquakes is all about seismology. Then it occurred includes in India, in Nepal, in Assam. Okay, then this is about small paragraph about earthquakes. So the main part starts from here. So what is seismology? Seismology deals with the behavior of the seismic waves produced by the earthquakes. Okay, the wave transfer energy from one place to another by vibration of particles. Okay, not matter but the wave transfer. Okay, wave transfer energy from one place to another via vibrations. Okay, okay, then we move down. This is an example given. When you throw a stone into a water, how does the water fluctuate into round circles, giving rise to ripple marks basically in water. Okay, then we move down. Main two types of particle motion occur in this instance. When particles oscillate perpendicular to the direction of propagation, such waves are called as transverse waves. Okay, when the particles oscillate perpendicular, okay, perpendicular means the perpendicular to the direction of propagation, such waves are called as transverse waves. And when the oscillations are parallel, matlab when the particles oscillate parallel to the propagation, those are called as longitudinal waves. Okay, so this is an important part about transverse and longitudinal waves. Then we move down. As the earthquake progresses, produces similar kind of waves in the earth's crust with transverse waves known as secondary waves. Okay, so transverse waves are called as secondary waves. Okay, also called as S waves. Transverse S waves denoted by the initials. Longitudinal waves are called as primary waves or P waves. Okay, then we move down. Origin of earthquakes. Origin of earthquakes. Then earthquakes are explained by plate tectonics or elastic rebound theory. Okay, plate tectonics or elastic rebound theory. Next, you can read about this, about the theory was proposed by who. Okay, in which year elastic rebound theory was proposed by who. Then you come down, all about the earthquakes given. Okay, then you move down. This is the part. The energy released by the earthquake travels through the earth in the form of waves called as primary P wave, secondary S wave, and the third type of wave is surface wave. So three types of waves: primary, secondary and surface waves. Surface waves are denoted by L and R. Okay, sudden breaking is called as rupture, usually results in tectonic forces develop strain beyond the limit of the strength, and due to that earthquake occurs. Okay, then you read about this. Then science of seismology deals with the fundamental concept of origin of earthquakes. Science of seismology, okay, deals with the concepts of origin of earthquakes, then and its tectonic relationship, behavior of rocks under different stress conditions, locating the earthquake, measuring the energy released by an earthquake, earthquake production and reoccurrence, building of earthquake resistant structures, and long term behavior of faults. Okay, so this entire paragraph is important. So science of seismology deals with these concepts. Okay, so even if you remember at least four key points is more than enough. Okay, then there are various terminologies used. Okay, so these terminologies are related to this diagram over here, this 7.3 diagram. So we'll just see what is about. Focus. It is a point within the earth along the fault plane where the earthquake originates. Yeah, so you can see in this diagram over here. Focus. It is the point along the fault plane. It is a point along the fault plane where the earthquake originates. So the origination of the earthquake is from the focus. So I'll say mark it originates. Focus is the origination point. Epicenter. This is the point on the earth's surface which is vertically above the focus. Vertically above the focus, you see. Epicenter. Okay. Just above the focus. It moves in a straight line above the focus. So I'll say it is vertically above the focus. Isoseismal lines. These are imaginary lines joining the point on the earth's surface which have same earthquake intensity. So at this point, you can see the isoseismal lines. Over here, these 1, 2, 3 lines are there which are connecting each other. So at this point, if there is an earthquake of the same intensity, even at this point the earthquake's intensity will be the same. So that are isoseismal lines. But these are imaginary, these are not present in real. Okay. Focal depth. Vertical distance between focus and epicenter of an earthquake is called as focal depth. Vertical distance between focus and epicenter. Yes, see, from here, epicenter to focus, this part. From here to here, this part is called as depth of focus or focal depth. Distance between epicenter and focus. Okay. Okay, next we move on to the next page. Depending upon the focus, 3 types of earthquakes are recognized: shallow focus, intermediate and deep focus. Shallow focus, the depth of focus is 60 kilometers from the surface. From the surface means from the epicenter till down, that is ranging up to 60 kilometers. Okay. Okay, these are large in number and are more disastrous. Okay. Intermediate, depth of focus from the surface is till down is 60 to 300 kilometers. Okay. Intermediate. And the deep focus is starts from 300 up to 700 kilometers. These are less disastrous. These are moderate. Intermediate are moderate disastrous. Okay. These are less disastrous. Okay. So this is about the terminologies of the focus, epicenter, isoseismal lines, and this is the types of earthquakes based upon the depth of focus. Okay. Okay, so our next part is the seismogram. So seismogram is an instrument that measures the intensity of the earthquake in the form of seismic waves. Okay, so seismogram is the record that consists of zigzag lines, just as your ECG machine. It is the same as your ECG machine. Zigzag lines that are intermittently recorded in between almost straight lines. So okay, so the zigzag lines represent seismic waves generated by the earthquakes, while straight lines are the characteristic of quiet time span. Okay, so where there are straight lines, that means the intensity is not that much, and where there are zigzag lines, that means that there are waves produced, there is some movement of the tectonic plates below. Okay, so this is a typical seismogram. Okay, you can see the P waves, the S waves, primary, secondary, surface waves, that is your L and R waves. See the intensity too much over here. Okay, this is your L and R, these are S waves, P waves, the time interval between S and P, between S and L and R waves. Okay, next move on to the seismic waves. The energy released by an earthquake is traced in the form of seismic waves. Okay, they are detected using an instrument, that is a seismogram. So seismic waves are of two types, body waves and surface waves. Okay, body waves and surface waves. Okay, they are for these waves are further divided into P waves. P waves, also called as primary or longitudinal waves. They are also called as compressional waves. Okay, they are also called as compressional waves, longitudinal or primary. Okay, these are the first to generate. Okay, and they travel the fastest at the velocities of 1.5 to 8 kilometers per second in the Earth's crust. What is the speed of light? 3.8 kilometers per second. Okay, these travel at 1.5 to 8 kilometers per second, almost that range. Okay, next is our S waves, secondary waves, also called as shear waves or transitional waves. Okay, also called as shear waves or transitional waves, secondary waves, travel at 60 to 70% the velocity of P waves. Okay, P waves shake the ground in the direction of propagation, and while S waves shake perpendicularly or transverse to the direction of propagation. Okay, so P waves in the direction of propagation, while S waves shake perpendicularly. Okay, so you can see the diagram over P waves, straight waves, S waves in a zigzag manner, and surface waves in a more cross sectional manner. Okay, the second type is a surface wave, which we did. These are body waves, two types. Next is a surface waves. Surface waves which travel along the surface of the earth, hence are called as surface waves. Also divided into L and R, as we discussed in the previous page. L waves move side to side. You see, okay, L waves move side to side like a snake. Okay, while R waves roll the ground apparently up and down. S waves is side to side, sorry, L waves is side to side, and R waves is up and down, apparently up and down. Okay, the surface waves are most damaging to property and infrastructure. Okay, then there is a small part over here. Although wave speeds vary by factor of 10 or more, the ratio between the average speed of P waves and of its following S wave is quite constant. Okay, so average speed of P waves to that of S waves, so they have represented V by P, Vp upon Vs. Okay, this is the ratio given. Okay, so this is equal to a constant, that is, you can say, take a constant as K. Okay, so then we move on to the next page. Okay, for quick examination, the seismologists multiply S minus P. Okay, for quick examination, seismologists multiply S minus P, that is a time, by the factor of 8 kilometers per second. Okay, this is an important part. Okay, 8 kilometers per second to get the approximate distance of an earthquake epicenter from the earthquake. Okay, this is an MCQ in the it had not come in the 2022, but it is a MCQ which is in the exercise. So I'll tell you up later, but this is the answer. 8 kilometers is the answer. Okay, then you move down. Both types of surface waves are slower than P waves. Surface, that is both, that is your L and R, both are slower than your primary and secondary, but are more damaging as compared to these two. Okay, but they are important to understand the geohazards due to greater damage on the surface caused by them. Surface waves are generated by most seismic sources and have largest amplitude. Okay, they are slow but they are more damaging as compared to P and S. Okay, that's the main inference you take from this part. Okay, next you move on, earthquakes and geohazards. Okay, so they don't ask much of questions from here because I'm just skipping this part. Okay, you can read it, they don't ask much about this. Okay, so there's 5 points, simple terminology is used, nothing much. Next you move on to locating an earthquake. Okay, so you come directly over here. Okay, so you have given a definition or something. No, when an earthquake occurs, the most urgent information needed is about the location. Okay, so without the location you will not come to know where the earthquake is locating. It is a sudden phenomenon and requires a rescue agency as soon as possible. The location of the earthquake can be immediately established by the finding the epicenter, as we said it in that diagram 7.3, epicenter just above the focus, by using triangulation method. Okay, so this also had not come in the 2022 MCQ, but this is a possible question by using the triangulation method. It had not come in the 2022, but I'm just giving you, it can come, triangulation method. How can the location of a earthquake can be found out? Sorry, you can say the location of the earthquake can be found out by using the epicenter, by which technique or by which method? Okay, so using the triangulation method. Okay, then you come down. Okay, this is done in your practicals actually, this diagram. Okay, the finding the triangulation method, here the epicenter is found out. Okay, you take station, they give you 3 things, you have to convert this kilometers thing into centimeters. So just it is 2500 kilometers, you convert it into 2.5 centimeters. This is your 3.5, this is your 4.5 centimeters. Okay, and where there is a point of intersection of all the 3 stations, that is your epicenter. Okay, so this is done in your practicals. Okay, then you move to the next page. Okay, this is your modified Mercalli scale table 1. Okay, this is a modified Mercalli scale. Okay, about the description is given in this paragraph. Earthquake intensity. So an earthquake is expressed by intensity and magnitude. We all studied in your 9th and 10th standard also. Okay, okay, an earthquake is expressed by its intensity and magnitude. Intensity is the severity of damage by an earthquake at a given locality or a region. Okay, this is a definition of intensity. What is intensity? It is the severity of damage by an earthquake at a given location or a region. Size of an earthquake is proportional to the effect. How much the earthquake has caused, that much will be the effect. Okay, so how do you measure intensity? Using the modified Mercalli scale. Intensity can be measured using modified Mercalli scale of 1931. It has 12 categories that is given in the table. Okay, it allows the intensity at each locality to be estimated after the earthquake. Okay, after the earthquake is produced, then only you can come to know the intensity. Okay, by observing and defining the damages. How? This is the technique. How? By defining the damages with the recording done immediately after the earthquake. Okay, it's done immediately after the earthquake. What the intensity is measured. Okay, earthquake's magnitude. Okay, so intensity is done, earthquake's magnitude. We use the Richter scale to measure the amount of energy released by the earthquake. Amount of energy released is also called as the magnitude of the earthquake. Okay, so in this scale we use the amplitude is taken into consideration. Okay, the amplitude of the largest wave produced by an earthquake is corrected for distance and assigned a value on an open-ended logarithm scale. one order increase in magnitude of Richter scale correspond to 10-fold increase in amplitude. Okay, so if you didn't understand this, you can look at the diagram over here. This is the distance, magnitude, amplitude. Okay, so if you see over here the distance, the amplitude over here, okay, the distance, magnitude and amplitude, distance and magnitude. Okay, and this all things are given on a logarithm scale. So yes, this is a logarithm scale. Okay, so I'll explain you this how it happens. So that whichever the largest wave is produced by an earthquake, that distance is taken into consideration, and that distance is measured on a logarithm scale. That is your log table. Not a log table, but there is a particular scale which measures this, which measures the earthquake's magnitude. So the amplitude of that largest wave is taken, and it is corrected for the distance on the logarithm scale, and in correspondence with that logarithm scale, the magnitude is defined for that particular earthquake. Okay, so 1 degree change in the magnitude corresponds to 10 folds increase in amplitude. So you can see over here, 1 order increase in magnitude on the Richter scale correspond to 10 folds increase in amplitude. Okay, so you, whatever I am saying, you got to write it down and note it down, then only you will understand. Okay, so this was a 2022 question, this for 2 marks, 2 marker question. This was 2022 question, 2 marks. Write about the earthquake's magnitude. Okay, so you got to write this entire paragraph. Okay, then we move down on the earthquake's belt. Okay, so earthquake's belt, a survey of Earth's seismic activity over the years reveals that majority of earthquakes are restricted to narrow and elongated zones on the Earth's surface, which are called as earthquake belts. Okay, so there are 3 types of belts: Circum-Pacific belt, Mediterranean Asiatic belt, and Mid-Oceanic ridge belt. Okay, so the 3 belts: Circum-Pacific belt, Mediterranean Asiatic belt, Mid-Oceanic ridge belt. Okay, for those who did not understand this part, 1 order increase in magnitude of Richter scale. So I'll just write something about this so that you get more clear idea. So okay, so excuse for my handwriting. 1 order increase, yes, I have shown over here, 1 order increase is equal to 10 folds will get increased at one particular time. Just remember this, that's it, you can just explain it in your own words. Coming back to this part, the 3 belt, Circum-Pacific belt. This belt runs along the margin of the Pacific Ocean through Japan, Philippines, Chile, New Guinea, New Zealand, Alaska, and west coast of North and South America. Even if you remember 3 countries, it's more than enough. Okay, the San Andreas Fault in United States falls in this belt. This you have to remember, San Andreas Fault in United States. 70% of deep focus earthquakes occurs in this belt. Okay, so 70% is Circum-Pacific. Second is Trans-Mediterranean. The belt runs under Gibraltar and Southeast Asia. It passes through the Mediterranean Sea, hence it is called as Mediterranean belt. Iran, Himalayas and Myanmar. 21% goes under the Trans-Mediterranean. Mid-Oceanic, this belt passes through the ocean floors of the earth. This was a 2022 MCQ. Okay, so 2022 MCQ. Okay, 2022 MCQ. The answer was ocean floor. So they had asked the mid-oceanic belt passes through where, like which part of the earth passes through the ocean floors. So this was the answer. Okay, next, moving on to the next page. Prediction of mitigation of the earthquake. Nothing much about this. They don't ask much about this, so we'll skip this part. Next part is seismic hazard zonation. Okay, in this also nothing much. Okay, now this part. Do you know Moho basic discontinuity? We studied in the previous chapter about discontinuities also. So Moho, this was a scientist, given about him everything. Okay, where it ranges from. Okay, next we move on to the next part of calamity is the landslides. Landslide is a naturally occurring phenomenon. Everything is naturally, even earthquakes are naturally occurring. Okay, so this also is a 2022 question. Okay, so this is a question which had come for 4 marks. Write a note on landslides for 4 marks. Okay, so this entire paragraph goes under that. Okay, so this is the definition: the downslope movement of rock debris or regolith. Regolith means loose unconcentrated mixture of soil and rock particles. Okay, regolith and soil in response to gravitational stresses is referred to as a landslide or a slope failure. Okay, so if they ask slope failure also is the same thing, mass wasting also is the same thing. Okay, this is the definition. 3 types of downslope movements are there, that is falls, slides and flows. This is downslope movements, okay, that is falls, slides and flows. This entire paragraph had to be come under that, that is your 4 marks. Okay, also this comes for 2 marks, your definition, okay, and the downward slope movement. Okay, the next 2 marks of this same answer goes for types of landslides. Okay, there are 2 types of landslides, that is rotational slumps, and your second one is transitional sliding. Okay, this is your next 2 marks. Your first 2 marks is that and that, second 2 marks is this and this. Okay, so rotational slumps are what? Involves a sliding along the curved plane. Okay, so sliding along the curved plane. Sorry, let me change the pen. Around the curved plane, producing slump blocks. Okay, transitional sliding is a downslope movement of the Earth's material along the planar surface. Okay, downward movement along the planar slip plane, such as a bedding plane or a fracture. Okay, okay, so understood rotational slump first, second is transitional. Sliding along curved plane is rotational, producing slump blocks. Okay, and planar slip movement is of transitional along a bedding plane. This is your rotational movement. Okay, this form you can see over here at the below, over here, this part. You can see over here the hummocky toe. Okay, these are slump blocks along the curved plane. So this is a curve. You can see over here, this is a curve over here. It is not straight, it is a curve. Okay, if you draw a graph of this, okay, if you draw a graph of this, so if you draw a graph, it will come somewhat like this. Okay, so it is along a curved plane, but rotational is along a planar surface. Okay, planar surface. Both are downward slope movement, but this is along a planar and this is along a curve. If you draw a graph of this, this will be like a straight line from here to here. Okay. Okay, understood the 2 movements. Now we move on to the next part of a small thing. Landslides are complex combination of sliding and flowage. Such complex landslides may form. Okay, so this is just read about this, nothing much. And then we move to the next page. Impact of geological structures on landslides. Okay, so this is 2 points to be remembered. Study of landslides on bedding planes ancestosity and foliation. Okay, just read about this. Okay, next part also is over here, joints. Okay, so it'll be easy because we have done the previous chapters. Okay, so just read, you will understand. Next part is you move to the next page. Our third calamity is volcanoes. So volcanoes also are of three types. So before going to the volcanoes, we will do this definition. A volcano is simply a vent at the surface of the earth through which lava and other volcanic materials are ejected from the earth's interior. Lava is termed for magma. Okay, lava in geological terms is called as magma that has reached the surface through a volcanic eruption. Magma is a molten material below the earth's surface. Three types of volcanoes: shield, composite and dome. Shield volcanoes, they are the largest of three. They are the largest and they are gently sloping. So this is an important, all three types are important. They mostly, this question is usually asked. Okay, though it was not asked in 2022, but it was asked in the 2023 question paper. Okay, gently sloping and built entirely of low viscosity, almost entirely low viscosity and basaltic lava flows. Okay, they are generally non-explosive due to low silica content. Okay, so these are the differentiating points. If they ask to differentiate between shield and composite, so you can say these points. I'll tell you how the differentiate goes further on. Okay, they are so you come down. Numerous small shield volcanoes are typically throughout the eastern Snake River Plain in USA, Wapi lava field, and you just remember one example is more than enough. Okay, and Helms half acre USA. Okay, so this is a diagram. Diagram is also important. Okay, so just show a schematic diagram, no need of drawing in much detail. Okay, composite, they are also called as stratovolcanoes and the most beautiful but the most deadly as well. They are steep sided. These are the characteristics: steep sided, symmetrical cones. Okay, they have intermediate viscosity, that the before one had low viscosity. Their basaltic lava flows, here andesitic lava flows. They are non-explosive. They are explosive with tephra as the explosive content. Gives rise to crude stratification. Okay, examples of composite volcanoes are Mount Shasta in California. So you just remember one example, easy example, Mount Fuji in Japan. Okay, you show the diagram as well. All diagrams of all three volcanoes are important, whichever you are describing along with diagram. And third is volcanic domes. Okay, volcanic domes is, these comprise the third primary type of volcano. These are formed from viscous rhyolitic magma. They are highly viscous rhyolitic magma flows, high silica percentage 70%. They are typically small as compared. Explosive also blow out during the building processes. Domes commonly occur adjacent to or within craters. They occur mostly adjacent or within the craters. Okay, example they have not given. They have not given an example. Okay, no problem. So moving next, volcanic hazards. In simple terms, you can just read. Then types of volcanic hazards. This entire diagram over here, this 7.18 is explained in this paragraph. Types of volcanic hazards. Each and every geological term is explained. Okay, so you just read it off. Okay, moving on to the next part, effects of volcanic hazards. Okay, so nothing much. Moving on directly to the exercise. Okay, so the exercise, the first question, downslope movement of rock debris in response to gravitational stresses is called as landslide. Debris or avalanches is a very rapid to extremely rapid debris flow. Landslides are a complex combination of sliding and flowage. Whatever underlining markings I've given that in the chapter, everything is MCQ related in the exercise page. Water contributes to dams when sediment pores are partially filled with water. gravitational forces. Dash is the most beautiful but deadliest. Composite. Dash slumps involve sliding along a curved slip plane, producing slump blocks. Rotational. Okay, everything I marked. Okay. For a quick estimation of the distance of an earthquake epicenter from seismic station, seismologists use a multiplication factor of 8 kilometers per second. Remember, I told you to remember 8 kilometers per second. Okay, so it's 8 kilometers per second. Next is the most common scale to measure the intensity of the earthquake is modified mercury scale, mm. I'll just write mm scale. Okay. Next, globally the earthquake occurrence belt coincides with the circum-Pacific. The first one, circum-Pacific scale. Okay. The ninth one is circum-Pacific scale. Yes, circum-Pacific. Oh, wait, it's not circum-Pacific scale. It is circum-Pacific belt, right? Yeah. Sorry, why am I saying scale? It's written belt over here. Okay. In Richter scale, the dash is the largest wave, the amplitude. Okay, let's write A, amplitude, because everything marked. Okay, I don't want to write again and again. Next is choose the correct alternative. Geohazards can originate. Everything is correct. Okay, so all of the above. The seismic waves can be correlated with the analogy of ripples in the pond for they travel away from the source. Elastic rebound theory of H.H. Reid explains the origin of the earthquake. I have marked even that. Maybe if you can recall everything, it's nothing hard. It's everything easy. The contours of imaginary lines on the map joining points of the same earthquake intensities are called as isoseismal lines. I told you the diagram is very important. Zigzag lines. Zigzag lines. What is zigzag line? It's seismogram. Seismogram. Yeah, seismogram. Okay. The instrument which records is seismogram, and the graph representing is seismograph. Okay. And the waves are called as seismic waves. Okay, so don't get confused. Sheet volcanoes are okay, they are largest, they're gently sloping, and the eruptions. So it's 1, 2, and 4. So it's B, right? Okay, so moving on. Okay, so that's it for this chapter. I don't feel there's any much thing. So this chapter comprises of 7 marks total had come from here. Not 7 marks, sorry. 4, 5, 6, 7. Yeah, 7 marks. 7 marks had come from here. If you move down, this question: in how many seismic zones in India are divided, and which country and which area of the country is the most susceptible to seismic hazards? Okay, this is this answer will not be in the textbook. Okay, so you gotta find it out from some reference books or from the net. Okay, rest all are from the textbook itself. Okay, but this question will not promptly, it will not come mostly. Okay, so yeah, that's it from this chapter. Okay, so I think I have this answer. The fourth question, as I said, there are 5 zones and zone 5. Okay, and this question, the next question: what are the major types of mass movements? Okay, so I'll say this, both answers have said. Major types of mass movements include rock fall, mud flow, landslide, and rotational slips. These are the major types of mass movements. Okay, so our next part is the remote sensing and the GIS, the next chapter, sorry. So you can see in the introduction part what is remote sensing. Okay, so the process of measuring the or acquisition of information of some property of some object or phenomenon by recording device that is not physical or intimate contact with the object under study. It's a very confusing one. Thus you can say it is a process of measurement of information of a particular property of some object. That's it, for the requirement of study purpose. Okay, these are the medical imaging, CT scan, MRI scan, sonography. Okay, this. Okay, Let's move on to the history of account. Okay, so there's nothing much in this chapter. The question which was asked in 2022 was a 6-mark question, 6 marks in total, segregating into 2 or 4 or 2 or 3 marks something. So directly move on to the important part. So among a very first civilian efforts mandated exclusively for Earth's observation EO in the Landsat 1, formerly the Earth Resources Technology Satellite ERTS-1. Okay, so you come down it's about the history, and history doesn't be asked mostly. I'm just giving you the underlinings so that you remember something about it. Okay, so who coined the first remote sensing? The term remote sensing was first coined by Miss Evelyn Pruitt of the US of the Naval Research. Okay, Evelyn Pruitt, remember her name. Then they have given you the Indian remote sensing satellite launched by ISRO. The launch vehicle, the status, and the date of launch, and also the satellite name. Okay, so they don't ask from here anything. Next, move on to this part. Resources Sat-3 is a planned satellite to carry atmospheric correction sensor ACS, and is stated to be launched in 2021. Okay, so atmospheric correction center to carry correction center. Okay, this is the satellite name. Okay, it's already launched in 2021. Okay, so the process of remote sensing satellite is given in this diagram. You can see over here the source of energy, propagation through the atmosphere, the Earth's surface features, then the retransmission through the atmosphere, sensing systems. Then you can see over here the sensing products, interpretation and analysis, information products, and the users. Which okay, so just know the terms. That's it. Nothing to remember from the diagram also. Next, move on to the next part. Directly you come through this classification and types of remote sensing. This is the most important part from this chapter. Classification and types of remote sensing. Okay, so there are 2 types of remote sensing, that is passive remote sensing. Okay, and there's a second one, active remote sensing. Okay, 2 types. So what is the first type says? This is an example of simple camera without a flash. You can give an example also. Okay, here it is an example of a camera, but now it is equipped with a flash for illumination. Okay, so passive remote sun is the primary source of illumination carried out by remote sensing satellite. So passive we have an illumination source. Okay, but in active we don't require we require an illumination source. That is why it is equipped with a flash. Okay, and in passive we already have an illumination source. That's the basic difference. Okay, next you come to the next page. The most popular and commonly used data for remote sensing light is usually the one collected with visible light or visible wavelength of light detected by human eye in the near infrared as well as thermal infrared wavelength. The visible and the thermal range is recorded by sensors called as multispectral scanners, also called as MSS. Okay, on board, and our IRS is called as LIS. Indian remote sensing series is called as LIS. Oh. Yeah. Okay. Next you move on to the sources. Okay, so from here, this was a 2022 question. From which portal can we download digital data regarding remote sensing data? Remote sensing sources of remote sensing data. 2022 question. Okay, so for 1 mark it had come. MCQ it was. Okay, so that is the Bhuvan portal. Your answer is your Bhuvan portal 2022 question for 1 mark. Okay, this is the next important part of the chapter, orbits of remote sensing. Okay, all remote sensing satellites are placed in a low earth orbit. Okay, so what is the full form of low earth orbit had come in the 2022 question paper. So okay, so even easy questions, even full forms like questions can come. Okay, so low earth orbit was the answer, full form of LEO. Okay, then our next type is our sun synchronous polar orbit, which is your second type, which you learned in 10th standard, I guess so. Okay, your low earth orbit ranges from 300 to 700 kilometers above the earth. Okay, then you come down. Communication satellites are placed in geostationary orbits, which is about 36 to 41,000 kilometers above the earth's surface. For India's, we have INSAT series of satellites for television signals. Next, we move on to the next part, is directly come to the next page, satellite imagery. Remote sensing satellites record data in digital form, and data is collected in discrete wavelengths. The distinct range of wavelengths are called as bands. Okay, so there are multiple bands. Even this you studied in your 10th standard, I guess so. Okay, so this is the satellite, Indian remote sensing satellite P6 LISS, linear imaging self scanning LISS, senses this 4 types of bands. That is your band 2, band 3, band 4 and band 5. You have to remember the band number along with the color. If you remember the wavelength which is given in micrometers, it's very good. Okay, so not easy to remember all 4, you might get confused. Okay, so just remember the band number along with the color. Okay, band number along with the color. Next we move on to band 1. Okay, so band 1 is always blue color, but it has been discontinued for a particular reason. Why it has been discontinued? Because in many IRS satellites, because of its limited use and lack of clarity, and due to sensitivity, not it is very sensitive to water vapor in the atmosphere. That is why it has been discontinued. Okay, this was also a question which was asked in 2022. Why has the blue band or band 1 been discontinued? So this was a question, this one. Okay, I'll write over here, 2022 question. Okay, so the answer was due to lack of clarity and sensitivity to the atmosphere, water vapor. Okay, so your next part is types of satellite imagery data. First one goes as, there are 3 types: panchromatic, color composites and true color composites, and false color also as well. Majorly there are 3 types: panchromatic, color composites. Color composites has 2, true color and false color. So panchromatic, there is a single band image in this, but the data is very high ground resolution, that is why it is considered. We use pan sensor of Cartosat 2E. Okay, this takes black and white images. Panachromatic is also called as black and white images, panchromatic. Okay, and it takes the portion of the visible and the near infrared spectrum. Resolution, they've given the wavelength and the resolution. That's it, just remember what I've marked. Okay, color composites, imagery requires multiple bands for color composites. Okay, so primary color bands are, we have 3 primary color bands: blue, green and red. You've seen over here, band 1 is blue, green and red. At any instant, we just use 3 bands to create color composites. There are 2 types of color composites: true color and false color. Okay, true color composites. True color means you assign the same color band as the color of the wavelength range of band. Suppose the wavelength range of band is blue, you have to select the same color for the particular band. Matlab assigning the same color to the band as the color of the range of that wavelength band. So as now, if the color is same, so automatically the image will appear identical. So image will appear identical to the color of the earth surface. Okay, so this way, so basically Google Maps uses this technique. Okay, Okay, best example is Google Maps are an example of TCC, true color. Same band color as the same range of wavelength band for that particular wavelength. The range for that is the same as the band color. So automatically the image appears identical, and hence Google Maps uses this technique for true color composite. Next is your false color. False color is what? The band color will not be the same. Yes, see, assigning any of the three primary band colors to related bands where the assigned color does not match the color of the wavelength of the band. But if this is blue, that will be green. That will be green, that will be red. Blue, red, vaisa. The special type of FCC is standard FCC, where the green, red band and near infrared bands assigned blue, green and red. Okay, so this green will be assigned blue, red band will be assigned green, near infrared will be assigned red. Okay, so remember this: green, blue, red, green, near infrared, red. Okay, so hence the identical image will not appear the similar. Okay, so this is helpful in demarcating forest areas, cropland, grass, high biomass covers of area. Yes, see. Band, yes, see. Blue, green, red, near infrared. Ulta, green, red, blue, near infra. Okay. Okay, so over here we forgot something. Yeah, elements of image interpretation. Even if you remember the terminal, just starting shape, size. Okay, shape, size, then pattern. Then what is given? Association. Just remember the words, tone. Okay, and that's it. One small example you give, that's it, you're done. Okay, next we move on to aerial photographs. Aerial photographs are photographs of the earth surface using cameras or digital films. Okay, and drones such as UAV, unmanned aerial vehicles. Okay, best example is drones. Okay, your next question is what GIS, right? GIS, what is the full form of GIS? Geographic Information System. This is also a question asked in 2022 for MCQ, for 1 mark. MCQ, full form of GIS, full form. So you have encountered 2 full forms so far from this chapter. Okay, next we move to next part is just remember this scientist name. He's not a scientist actually, he was a geographer. Who is the father of GIS? Dr. Roger Tomlinson. Okay, this can be asked as a MCQ also, can't say. Father of GIS. Okay. Okay, then you move to the next page. Nothing much about this actually, but I'm just marking this paragraph. You just read it. Okay. Next move on to the next part is GIS generic questions. This also is nothing much. Okay, you just read about this. Okay, this is an example given. Just read about this also. This is the second example given. It is about the patterns and relationship. Okay, chal, I'll do it. And these are the trends. So pattern relationship, does feature X occur in a pattern? Yes, in a line from northwest to southeast. Feature X, northwest. Okay, over here, northwest to southeast. Okay, is there a relationship between X and Y? Yes, Y is always close to X. You can see over here, Y is always close to X. Here also. What other spatial or functional patterns exist? Feature Z is always near the border and increases in size from west to east. Yes, see some Z, it increase. Here also it increase. Here it increase the largest. Smaller, then little most bigger and biggest. Okay, the same is goes with trends. How did ABC change from 2010 to 2020? Increase in size. Some B decrease in size. C change shape. Okay. Next is what has changed since 2010? Size change, location change, shape change, and another addition of another component, addition of D. So it's the trends. These are patterns in relationship. This can be not asked but can be. Application, DMM, disaster management and mitigation. Okay, then natural resources and water. Okay, 3 examples. Just you can write it in your own words also. I can't say everything because then I will be saying like you learn everything. Okay, you can write it in your own words. Just remember the key words so that your question is answered according to your correct answer paper. Next we move on to, okay, these are the satellite maps actually. Okay, so this there are how many maps given? I think so there are 4 maps given. Satellite imagery, not maps, the satellite imagery. This will come in your practical for identification of folds and faults and all those. Moving on to the exercise, the term remote sensing was first used in the year 1929. Evelyn Pruitt, as I've told you. Civilian remote launched by USA was ERTS-1. It was later named as Landsat. This is an important, okay, Landsat. The first Indian remote sensing satellite was IRS-1A. IRS-1A was launched in the year. So all MCQs are related to each other. Like these two are related, these two are related. The RISAT in India's first satellite was India's first radar satellite. Most remote sensing satellites cannot collect image data during winter. Abbreviation, geographical remote information. Geographical also you can say, geographic also you can say. 2022 question, same one had come. GI has the ability to this is imagery. Okay, the dash is not an example of remote sensing, is sonography. Sonography is not related only, right? Vegetation, dash is not an example of remote sensing. Okay, sonography, correct. Okay, that is scanning techniques, imagery techniques. Vegetation in a standard FCC appears red, right? Red, I'm not sure. Yes, it is red. Vegetation appears red in FCC, false color. Yes, red, correct, red. Okay, so dash is not an example of remote sensing. Okay, drone photography. Dash is not an example of passive remote sensing, lidar, whatever you call it. Dash is not an Indian remote sensing satellite. INSAT is of US, right? Today a remote sensing satellite cannot detect underground oil reserves. A remote sensing satellite is never in sun synchronous equatorial orbit. Okay, it is always in the geostation. It is always in which orbit? I've told you, right? It is always in a particular orbit. Which question? I forgot it. Here it is. Yes, it's sun synchronous polar orbit. Okay. Next, we move on to the next part is this is very short answers. List the 2 types of remote sensing, active and passive. Okay. The most I'm giving you this because these are not given in the textbook. It is related thoda bahar ka diya. Okay, the most commonly used data from remote sensing satellite is okay, 1 minute, we'll leave this question for now. Remote sensing satellites are usually placed in what kind of orbit? Sun synchronous polar orbit. Okay, in which form do remote sensing satellites record data? What are the bands in remote? Okay, this is simple. This is all given in the textbook. What are the types of color composite satellite? True and false. Okay. Okay, yeah, okay. The most commonly used data from remote sensing satellite is visible near infrared and thermal infrared wavelength. Yeah. Okay. So one more question over here. List the 5 elements by which interpretation of satellite imagery can be accomplished. That is your shape, size, pattern, tone, association. Okay. Okay, so that's it for this chapter. So finally we have finished our entire geology series of our video lectures. So I hope you have enjoyed it. The question papers will be shortly provided in the description box and also in the comment section as a form of a Google Drive link. So please refer that and make sure that you solve the questions and see all the videos thoroughly. If you do not understand anything, please mention it in the comments. Thank you for watching and subscribe for further notifications. Thank you.